These videos are for April 6th, April 7th, depending on if you're A or B day. We're looking at how we can solve logarithmic and exponential equations. This will be on your assessment. A lot of people are out this day, so I really hope that, well, I don't know why I'm saying this, because if you are watching, then you're doing what you're supposed to be doing, which is great. But let's see if we can solve these equations. These first four equations on our notes, these would be considered exponential equations. And the reason why we would call these exponential equations is because, well, look at where your variable is. In each equation, our variable is in the exponent. And so because that's true, that's why we call these exponential equations. Now, let's go ahead and maybe get to a certain place with these two equations, and then we can jump down to here. Let's say we want to solve this equation. Maybe subtract 1, we're trying to get x alone. That's what we mean by solve. So we have 64 equals 4 to the 2x minus 7. Now, what's happening here is it's not 4 times 2x minus 7, so we can't divide by 4. The 4 is being what's raised to a power. Our variable is in the exponent. So if it were like x squared, we take the square root, we're good, moving on, no big deal. But it would be great if we could figure out how to get variables out of the exponent. And we can do this. The way we get variables out of the exponent is logarithms. So now that we have our base isolated, we can change this into a logarithm and see if that helps us solve. So if we do change this to a logarithm, what this would become is log. Our base is 4. What's going to go inside the log is opposite of our base. So the 64 goes inside of our log. And on this side would be 2x minus 7. I'm going to come back here. Let's jump over here. Similar thing here. If we want to solve it, right? Plus 5. Now we haven't isolated our base yet. Our base, with the value that's being raised to the exponent, is only e. So we still need to isolate that e. So we do need to divide by 4. And then if we want to change this to an exponential, our base is e. So instead of log, we say ln, because our base is e. Anytime our base is e, this stands for log base e. Of opposite of our base is 15 equals x minus 1. Now, if you need to pause it, rewind, fine. That's all good. But we need to be careful with these two equations. Here, let's rather stay here. Here, ln of 15. Again, logarithms, we need to be thinking e, our base, raised to what power gives us 15. Well, we can figure that out, but it's not going to be a very whole rounded number. So if it's going to be irrational, we leave it like the 15, like this. And we could keep solving for x by adding 1. And so we get ln of 15 plus 1 equals x. And that would be our solution. Let's see about here. Here, we need to think about 4. Does 4 raised to a power, a whole number, equals 64? And it does. 4 raised to the third power. 4 times 4 being 16, times another 4 would give you 3. So this logarithm evaluates to be just 3. And now we have an equation that we can solve by doing our inverse operations like usual. But we should, on your assessment too, you'll need to know that. You'll need to know that the base raised to what exponent gives you this value. If it comes out even, we must replace it to ensure that we get a more accurate solution. All right. I'm going to talk about this one, give you the solution for this equation, and then probably in that video go to the next one. here in this equation, a lot of people struggle with this, and it's okay. Let's see if we can parse it out. What if I give you the equation e to the x equals e to the fifth? A lot of students will jump on board and say, yeah, x equals 5. No big deal, moving on, all's good. But when we look here, we start to struggle and try to figure out how can we do that, because we have two bases, and we can't get the isolated base like this, so what do? The concept is the same. Anytime we have a base isolated on both sides of our equation, and there is math behind this. I mean, if you want, I can show you an idea behind this. It's not just tricks. But even if this is the case, we can ignore the bases and just set the exponents equal to each other. Oh. All right. And we showed this in class. In a lot of classes, we talked about using the properties of logarithms and logarithms to get to a value to show that this is true. Now from here, we have a quadratic form. Ooh. Let's subtract 3x out of 4. This doesn't factor, so you would need to use the quadratic formula to solve this equation. Key concept is this though. If the bases are the same and they're isolated, then we can ignore the bases and solve that equation. This changes the second we add or subtract anything else. So if I do plus 2, that changes it. We can't ignore the bases. If I add plus x, that changes it. We can't just ignore the bases. This is only true if the bases are isolated on both sides of the equation. All right. All right, let's go. I'm not even going into it. I'm going to let you try to solve this in the same vein that we solved this one. If you did, you should get, let's see, this solution. So see if you get to that solution by solving this equation in a similar vein that we did the first two. If you have questions, please bring those to the to review day, or ask me through the Remind app email and those things. In the next video, we're going to look at solving logarithmic equations, and I'm going to let you try some on your own as well.